And so what we're going to do today is we're going to focus specifically on Algebra 1. And what I did is I went onto something that's called the blueprint. And what the blueprint is it tells us what are the things that you need to know and how many questions there are. So, for example, your test that you're taking coming up, it's 50 minutes long. So that means that you have to answer all of those questions in just 50 minutes. And how many questions you have is you're going to have 8 questions that are considered DOK1. DOK1 questions are questions that you either know how to do the problem or you don't know how to do the problem. We have another person coming in. Good morning, welcome. So 8 of those problems are just going to be simple math. They're not going to be confusing as long as you know like what the math is. 16 of the problems, so 2/3 of them, are going to be problems that are a little bit more challenging. So we're going to practice some easier problems and some harder problems. Now, Mr. McCurley, who is a geometry teacher, what I did is I stole his idea. What he did for his students is he picked the standards or the topics that had the most questions coming up on the test. So then that way, the kids, hopefully if they got that right, they'd get everything else right too. So that's what we're going to look at. So we're going to look at 5 different standards. There's a bunch of questions. And then around 11 o'clock, I do have a Kahoot on domain and range that we can play also if you guys are still on and you want to play. Obviously, I'm not like, this is Saturday. So if you want to get up, you get up and go to the bathroom, you get a drink. It's whatever you need to do for you is totally fine. And then this video is completely recorded. So if you get stuck anywhere, please just put your mic on and tell me you need help. Or you can type something in the chat box and then I'll stop and I'll answer your question. This is all about you and what you need. Okay. So the first thing we're going to talk about is over here where we're going to talk about, where's my mouse? There it is. We're going to talk about adding, subtracting, and multiplying polynomials. There's 2 questions on that. And both of those questions they have down as they're relatively easy. So because of that, we want to make sure that that's one of the focuses that we do, just because hopefully it would be like an easy A or an easy you get it right question. So that's one of the first things we're going to look at is that. Then we're going to talk about, I think I took the radicals out. We probably aren't going to hit radicals because we were running out of time. There's 3 questions on solving linear equations and inequalities. So we'll take some time looking at that. Going to the next slide. There's 2 questions on domain and range. So that is why I have the Kahoot plan for us to do that piece. Then there's 4 questions on functions. So I have a lot of practice on functions because hopefully you'll feel more confident and those will be the questions that we can really hope will help you get through the midterm. And then there's also a couple on slope intercept form. So let's take a look first. Again, have paper and pencil ready. Put your mic on if you want to. You can totally do that. No pressure at all. And I don't want it to be me just talking the whole time. So since you guys are new to how I teach, please put your mic on. Please ask questions. Go ahead. So here, this says, what is 3x squared times the quantity 2x minus 5? Now, I'm going to pretend that you have never learned this before. So there's going to be some topics that you think might be like super easy and why is she going so slow? Because some kids don't know it. So that way, when you rewatch this video, you can fast forward a little bit if you need to. So here it says, what is 3x squared times the quantity 2x minus 5? Now, I know that this is quantity. And whenever I think of quantity, I think about multiplication, of course, but I think about being fair. So it's kind of like if your teacher went into the classroom and says, okay, I'm going to give 10 bonus points to the second person who walks through the door just because they were the second person. That wouldn't be fair. Whatever you do to one student, ideally you would do to all of them. So that's what multiplication is about when it comes to algebra, is whatever you do to one thing, you need to make sure you do it to all of them. So for example, here I'm going to take the 3x squared and I'm going to multiply it by 2x. But if I multiply it by 2x, it's kind of like I'm ditching the -5. And we don't do that. In multiplication and in mathematics, everything has to be balanced and equal. So if we do 3x squared times 2x, we also have to make sure that we do the 3x squared times the -5. And that will allow us to make sure that everything stays balanced the whole time. Now, if you're comfortable, I'd love you to put your mic on and tell me how to do this problem, but I'll keep going if you don't want to. Basically, when we look at this problem, we have to look at the coefficients. Coefficients is just a fancy way for saying the number in front of the letter. So for example, here I have 3x squared. the 3 is my coefficient, the x is my variable, and the 2 would be considered my exponent. So in order to do multiplication, all we're going to do first is we multiply the coefficients, so we multiply the numbers. Then we write our variable or letter, and then we add the exponents. So right here, I've got 3 times 2, which is 6. So we did that first. Good. Then what we're going to do is we're going to write down our variable. So that gives us x. And then we have to look at what are the coefficients, or I'm sorry, what are the exponents. So here I have an exponent of 2. Does anyone know? You can either put your mic on or you can type it out. What would my exponent be next to just the x? Be brave. Someone be brave. Okay. It's 1. So what happens is because there's no number there and I do see an x, it's like it's 1. So if you think about it, like this is a pen. How many pens is it? 1 pen. I'm not going to say I have 1 pen. It's like I have a pen. If I have nothing in my hands, then the exponent would be 0 because there's no pen. There's 0 pens, so it's 0. So in this case, it's 1. So I would just do 2 plus 1, which gives me my exponent of 3. Now I'm going to look at this one. Now I typically have my kids put a plus sign just so that they get used to paying attention to whatever the negative is. So now I'm going to multiply my coefficients again. I've got 3 times negative 5. That's going to give me negative 15. Then I do my exponent, or I'm sorry, then I do my variable, which is x. And then I look at my exponents. And this is where we get to what I was just saying with the no pen. This one, we know our exponent is 2, but there's no x here. So because there's no x, there's no exponent. So really, our answer would just be 2 for the exponent. So when I simplify this whole idea, I'm going to be left with 6 and the negative 15. So I've got my 6x cubed minus 15x squared. And the reason why I didn't make the 6 and 15 go together is because I've got the x cubed, and that's different than x squared. Yes, they're both x's, but they're still different. It's kind of like I have 6 apples minus 15 grapes. They're both fruit, but some are apples and some are grapes, so I can't do anything with it. So that's how we do that problem. Okay, and let's look at another problem. Now it says, what is this expressed as a trinomial? So again, your teachers might have told you something called FOIL, which is an acronym that stands for first, outer, inner, last. Your teachers might have also showed you something called the box method. So I'm going to show you 2 different ways that you can do this problem. First, the way I always taught my students, because I didn't learn the box method till way later, is first, outer, inner, last. So what that means is first I'm going to go to here and I would multiply my 3x times my x. So I'm just gonna, I do everything really slowly when I do the video, so later people can fast forward if they need to. So I've got 3x times x. That's gonna leave me with 3x squared. Then that's my f. Then I do my outside. Oops, and my outside, all right, let's see, maybe if I move my head. Come over here, head. My outside would be the 3x here and the 2, because they're both on the outer sides of the parentheses. So I've got 3x times positive 2, which will leave me positive 6x. That's the O. Then I've got my I, which stands for the inside. So that's this -1 and this x here. So I'm just going to write -1 times x. And that'll give me -x. And you could write -1x, but it's not really proper math, so you typically wouldn't write it. And then finally, I've got my last, which is what comes the last in the binomials, which is -1 times 2, which a negative times a positive is negative. So this is what it would be kind of expanded out, but now I need to simplify. I need to do something called combine like terms. So when I combine like terms, I think, okay, here's 3x squared. Is there anywhere else that I see x squared? No. So I'm just going to write down my 3x squared. And I'm going to write it in that magenta. So here's our 3x squared. Then I say, okay, do I have any, my next term is x. Do I have any other x's? Yes, here's an x here and here's an x here. So I have $6, think of x like dollars, minus $1. How many do I have left? I have $5 left, so that'd be plus 5x because those two combine. And then I have left that constant, and a constant is basically a fancy way of saying a number without a letter next to it. -2. And that's my answer. So again, if you have any questions, please jump into chat, let me know, and I got your back. Moving on, this one's a little bit longer. This one, I'm going to do the box method, I think. No, I still like to do it the long way. Let me show you the box method real quick over here, just in case you are a box method user. I'm not, but just in case you are. For the box method, you would write it 3x minus 1, x and positive 2 this way. Then you multiply what's 3x times x. That would give you 3x squared. Then you multiply x times -1. That would give you -x. Then you multiply 3x times 2. That would give you positive 6x. And then you multiply 2 times -1, and that would give you -2. Then what we do is when we look up here at our different, come on, friend. When we look up here for our different values, we see that we have the 3x squared. We see that we have the -x and the 6x line up. So when we combine like terms, that gives us the positive 5x. And then we have that -2 all by itself. And that comes here. So that's the way that you can do the box method, is you put the top that way and then you go down. So I guess let's try the box method for this one because some kids really, really like it. So again, for me personally, I always put the longer, whatever I'm multiplying by, so in this case, the trinomial, on top. It's easier for me. So I'm going to write down 4x squared here, leave a space, put my positive 2x, leave a space, and put my -3. And then I'll separate that going down. This way I've got my x, and I've got my -2. And then here we've set up our box. So again, all I'm doing is I took each one of these terms and I wrote it down. That's it. It's not anything math. All I did is I wrote it spaced out. And then I took the x minus 2 because it was only 2 terms and I put it down. You could have done it the other way. I just like to put the longer one across. That's my personal preference. So when I do that, I'm going to go ahead and do my multiplication. So here I've got 4. Nope, wrong pen. Here I've got 4, and there's no coefficient here, so I'm left with 4. Then I've got x squared, and remember we add the exponent. So here there's no exponent, so that's really just a 1. So here I'm going to write down 4x cubed. Then let's keep multiplying across. Here's 2. This is a hidden 1. 2 times 1 is 2. Then I write my x's, and there's no exponent here, so I know it's 1. So I'm going to add 1 plus 1, and this is going to give me x squared. And then here, I'm going to do -3 times 1, which is -3. There's no x's there, so I'm not even going to think about that x, but I will write the x that's over here. Then I look at my next line. I've got 4 times -2, which gives me -8. And that x squared just hangs out because there's no other x's to multiply. I just got to bring that baby down. Positive 2 times -2 is going to give me -4. Bring that x down because x times nothing is still x, or I mean technically x times 1. And then -3 times -2 gives me positive 6 because a negative times a negative is positive. Now here's what's really cool when you do the box method, especially when it gets ugly like this. Everything works on a diagonal. So first, I've got this box right here. That's my first one. So I'll write down 4x cubed. That's my first term. Then, because everything works on a diagonal, I have this -8x squared and this positive 2x squared will match up. Everything matches on diagonals. So I've got -8 plus 2, that's -6, and then my x squared chills. Then I move to my next set of diagonal boxes, and I've got my -4x here, I've got my -3x here, a negative times a negative is positive, 12, and then the x. Wait, that was wrong. Don't listen to me. I had a brain fart. We have to add. -4 plus -3 is -7. And then the x hangs out. And then I'm left with my last term, which is just plain 6. And that'll just be here. So that is how you do the longer ones. So remember, there's 2 questions on your midterm. Both of the questions are going to be very cut and dry and simple, kind of like that. Here we've got subtracting. Does anyone know the word that makes it really challenging here? Anyone know? You want to go into the chat box or put on your mic? Be brave, communicate at all. There's a word that makes it really tricky. Okay, that word is from. It says, what is the result of subtracting blah, 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 blah from blah, 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 blah. That's one reason why it's tricky. Whatever is from, that is first. So all that means is first, I'm going to write whatever comes after the from. So I'm going to write 5x squared plus 3xy plus 6y squared. And I do that because it says, what's 10 from 25? Well, you have to have the 25 to start, and then you take away 10. So what's blah, blah, blah from blah? You put your blah first, from first, and then whatever was actually written first goes on the bottom. So that's our first equation. Then what you do is you write your second equation. I like to write mine underneath. I'm a very linear person, so that works for me doing it this way. Now, here's the other thing that makes it tricky. So the first thing that makes it tricky is the word from. The second is the word subtract, because subtraction makes us have to change all of the signs. So what's going to happen is, for me to do a subtraction, I can't subtract something very long. I have to distribute that negative across. So in order for me to do that, I'm going to change all of my signs on the bottom. And basically the reason is I'm really subtracting this whole thing, so I'm distributing the negative to each one of these ideas. What I tell my students to do is write the subtraction like this and then change every sign. The subtraction becomes positive, this positive becomes negative, this positive becomes negative, and this positive becomes negative. Now that I've changed my sign, I've turned it now into an addition problem. And addition is way easier than subtraction for some people. So I've got 5. And I'm adding a -4, so that's like 5 minus 4. That's going to give me 1, but remember, we don't write our ones, so that's just going to leave me with x squared. Here, I have +3, and I'm subtracting, and look at everything matches. X squared, xy, xy, y squared. Because everything lines up because of how I wrote it, all I have to do is look at the coefficients and drop the variables. So 3 minus 3 is 0, so we don't even have to do anything there. We're just going to leave that blank. And then here I've got +6 and a -2. That's going to leave me with +4, and then that coefficient comes down. And for our purposes, I'll write in the 0xy. Now that this is 0, I know all of this becomes 0. So the pretty way of writing this is x squared plus 4y squared. And that's it. Okay, we're going along. You're doing good. You're not communicating, but you're doing good. Okay, next is sum. So I showed you the subtraction first on purpose because I wanted you to think switching signs, but I want us to practice adding one more time. Remember, sum is addition. So again, I'm going to write everything up. I notice here that this is 3 terms, and I notice here that this is 2 terms. So for me personally, I always like to put the longer one on top because it's just easier for me. You do what you want to do, but for me, I always put the longer one on top. So I'm going to write down 4x squared plus x minus 8. And the other thing that worked out really well is, look at this goes in order. It's in standard form, x squared. Then this is really x to the first, so it goes 2 is an exponent, then 1 is an exponent, and then there's no exponents because there's no x. So I have that, but here's where it's tricky. Here we have to pay attention to what this is. This just says x squared, and then it tells me 9. So I'm going to have to make sure I line up my x squared so that way it's all pretty and linear. I don't have anything that has x next to it, so I'm not going to write anything there. And then I have plus 9. So when I add going down, because this is an addition problem already, I'm not changing signs. I changed signs in my other problem because it started as a subtraction and I had to make it into a pretty addition problem. Here it's already addition, so I don't have to do anything. I just leave it. in terms of not having to change the signs. Now I can do my math. So here I've got 4. And because I know that there's nothing written, this is really like a 1. So I've got 4 plus 1 is 5. And then that variable just jumps down. Then the x falls out. And then I just do the math on my calculator. -8 plus 9. It's like you owe your mom $8, but you give her 9 instead. You gave her an extra $1 plus 1. And that's it. Okay, we're almost done. This is our last one that deals with this kind of funkity-dunkity stuff. This is the easiest of all of them. This one is a straight sum problem because sum, of course, means addition. And look at, we have 3 terms here and we have 3 terms here. So we're going to write it out. It doesn't matter which you put first. I'm just going to write the first one first, but you could put the second one first. Then we write our next part. And then we always make sure that everything lines up. And we are adding. So because we're adding, we do not change any signs at all. We leave the signs the same. So then everything matches x squared, x, and then no coefficient. So now I just add the coefficients going down. 5 plus 3 is 8. So I'm left with 8x squared. -3 and -4 is you owe your dad $3. Then you owe him $4 more. How much money do you owe altogether? 3 and 4. You owe $7. But of course, dude, use a calculator. And then +2 minus 1 is still going to be positive, but +1. And then that problem is done. So according to the blueprint from the county, you are going to have 2 questions that are just as simple as these. So whether it's addition, like we just did, it might be a little tricky like this one of how we had to leave that space underneath the x because there wasn't an x term. Or if it says subtraction, this is still considered easy to the county. So just make sure when it says from, you put the from first, and then you change the signs of what you put underneath. For the multiplication, I like to just put it long on the top and the shorter one here, and then you can do the box method. And then, of course, the basic binomial multiplication. Does anyone have any more questions about that? Okay. If you do, you can still type and we can always go back. All right, next. This one is weird because I pulled this question from SchoolNet, which is where you take your tests. But I'm not perfectly confident this question is completely related to the standard. So I'm still going to do it because you need to know how to do it in algebra. But I have some other examples just in case this didn't match up and someone put the wrong standard in. So let's look at this. It says, Blake, hello, Blake. Blake is going to be increasing the amount of biotin in his diet. Biotin is used to help you have good hair and good nails. By eating peanuts, eggs, and carrots. The first week, he ate 4 servings of peanuts. Okay, good for you. 4 servings of peanuts. I hope Blake has the metabolism for that. He ate 6 servings of eggs, and he ate 3 servings of carrots for a total of 171.42 micrograms of biotin. The second week, he ate 2 servings of peanuts. So let's do that again. This time I'm going to change my color. So we've got 2 servings of peanuts. Notice I'm just color coding. It makes my life easier. He ate 4 servings of eggs. 4 of eggs. And he ate 4 servings of carrots. I guess I probably should have just made the carrots orange. Oh, well. For the total of 108.96 biotin. The third week, holy moly, this is a long problem. The third week, he ate 1 serving of peanuts. He ate 3 servings of eggs. He ate 2 servings of carrots for a total of this, 62.48 micrograms of biotin. So using the system of equations, and it tells us the letters. What are we going to do? Okay, hold on. Someone might have just direct messaged me. Nope, we're good. Okay, so what do we do? Well, I color-coded it for a reason because it makes my life super easier. First, let's look at peanuts. Okay, and peanuts I wrote in yellow. So it told me he ate 4 servings of peanuts, and down here it told you peanuts is P. So all I'm going to do is for the first one, I know he ate 4 servings of peanuts. I know the second week he ate 2 servings of peanuts, and I know the final week he ate 1, but I'm not going to write the 1 serving of peanuts. Okay, so I'm just going to go step by step. This is week 1. This is week 2. And this is week 3. So now let's look at the next one. Let's look at what he did for eggs. So for eggs, he had 6 servings of eggs. So because he ate it, we're going to do plus 6. So plus 6 servings of eggs. Then he had 4 servings of eggs the second week. And he had 3 servings of eggs the third week. Now, you could have done it. I'm using multiple colors, so it's easier for me to do all the peanuts, all the eggs, and all the carrots. But you could easily have just done it, and since you're using pencil, all the way across. You could have done 4P plus 6E plus, if you're communicating with me, you would tell me 3C is next. But it's however you want to do it. It's just easier for me to only switch it once every time, so that's why I'm doing it this way. But then it says plus, then he ate 3 servings of carrots is C. He ate 4 servings of carrots the second week, and he ate 2 servings of carrots the final week. And all of that equals the first week, 171.42. Let me write that again because I'm going to post the answers. Micrograms, the second week, it equaled 108.96. micrograms, and the final week it equaled 62.48. And that's the whole problem. So this was a multiple choice question, and it had all like series of systems of equations. I didn't want you to see the multiple choice answers. I wanted to work it out, so that's that problem. Let's look at another one just like that. Adam and Bree both collect trading cards. Adam has X cards. Bree has 5 more than Adam. So what I would do here, I can still highlight, but I'm going to show you another strategy. I'm writing Adam equals X, and Bree, so this video, when I'm done teaching it, is going to be uploaded to my YouTube channel and also at GwinnettMath.com where it said Algebra 1. You'll see the video there, and then you'll see the link to get the notes, and then you'll also see the link with the answers to the notes. So the video won't be posted till we're done recording it, and then after we're done recording it, it'll probably be posted like around 5 o'clock this afternoon because I have to then take this video and do some formatting and then re-upload it. So around 5 o'clock, you'll still find it at GwinnettMath.com. Good question. Thank you. Okay, so then we've got Bree. And Bree is 5 more than Adam. So I'm just going to put Bree equals Adam plus 5. Now, here's what's really cool. What does Adam equal? Dude, Adam equals X. So all I'm going to do is instead of writing Adam's name, I'm going to write X. So I know that Bree equals X plus 5. Okay, there are Y different combinations of pairs that can be made when choosing one of Adam's cards from Bree's cards. The number of combinations is also equal to 16 more than 5 times the number of cards that Adam has. So let's go back. It says the number of combinations. So I'm just going to put number. So the number of combinations equals, and let's go slowly, 16 more. So 16 more. So I'm going to put the plus 16 because it's, if I have 16 more dollars, I have the how many dollars I have plus 16. So 16 more than 5 times Adam. So 5 Adam. But again, we know that Adam equals X. So here I'm going to put 5X plus 16. Okay? And so here, see how it says Y combinations? All that means is instead of writing the number of combinations, I'm just going to write Y. Done. So choose a system of equations that can be solved for finding the possible number of cards that they have. So basically, here's a system of equations. So you would have this. You would have Adam equals X. Bree equals X plus 5. And then you would have your Y equals 5X plus 16 as a possible number of combinations that they could have. And that's it. Yep. That's it. Okay. Next one. Okay. So what is the value of n? So these questions are more what I think is supposed to come up. I found these questions from another site. So I think this is what you really need to know how to do. So this has 3 questions that you need to know for your test. One of them is going to be really basic, and 2 of them is going to be a little bit more challenging. So let's take a look at how we solve this. In this case, I'm trying to solve for n. So when I'm trying to solve for n, it's like n is the superstar and nothing else matters. So when I look here, I see that I have 3n on this side and I have a negative n on this side. Anytime I solve these equations, I always like to move my n's to one side, and I always move my n's to the side that has the bigger amount of n's. So here I have 3 noses, and here I have a negative nose. So I got to move it over to the side that has the 3. So I'm going to write this a little bit bigger because I write messy when I'm using my drawing pad. So the first thing that I'm going to do for my first step is I'm going to, some people say draw a river depending on who your teacher is. Some people say draw a line. I normally don't, but you guys, sometimes you're used to it. And again, this goes back to our first thing. We always want to make sure everything is balanced. So here I'm going to start off by adding n to both sides. When I do that, this eliminates it. It's like I have -1 plus 1 is going to give me 0. That's our goal. Our goal is to eliminate the n, and basically the terminology we're doing is called isolate the variable. That's what we're doing. We're isolating the variable. So I've got 3 noses plus 1 nose leaves me 4 noses. Then I'm going to, now I have all my noses on my ends on one side. So I'm going to move the 8 to the other side, and we're going to do the inverse operation, the opposite operation. See how this was negative? We did positive. That's what we're doing. Here it's -8. So now I need to do the opposite of subtracting 8, which is going to be adding 8. And again, whatever we do to one side, we always have to do to the next side. So that eliminates. Now I'm left with 4n. 32 plus 8 gives me 40. And then this is my first year. I only have like 2 football players, but I almost always have a ton of football players. When I think about the 4 and the n, I think about them like in a tackle. So it's like there was an amazing play. Our team, let's say, was on the defense. We went in, we did this huge tackle, and everyone's like this. Well, what's going to happen? Is the refs going to let you stay like that? No. What do you have to do? You have to divide each other apart. So here I've got my 4. Here I've got my n. They're in a tackle. What's going to happen? I need to divide them apart because they're in a battle. So what I'm going to do, my last step, is I'm just going to say, okay, whatever this coefficient is that's in front of the n, I don't want it anymore. I need to get rid of it, so I'm going to divide. 4 divided by 4 is just 1. So that leaves me with n by itself. Again, whatever you do to one side, you got to do to the next side. 40 divided by 4 is 10. So I'm left with n equals 10. So obviously when you're doing in this real life, you're not going to be needing to explain it, but watch this video as many times as you like. Last year, I tell this story a lot. I had a student who came to me one morning and he said, Doc, I went to bed with you last night. I'm like, dude, you can't say that in public. Like, what are you talking about? And it's because he got so used to just watching the videos as he was falling asleep. I don't know if that means I was super boring, but he would play the videos as he was trying to get to bed. So he would watch it. So he would just keep hearing it over and over. So that is how you do an equation like that. This is going to take it one step harder. So before, for the binomials, I started hard and got easy. This one I'm starting easy and getting harder. The first step I need to do here is I need to distribute. And we already talked about distribute before. We already said that whatever you do to one, if you gave 10 bonus points to one student for no reason, you really need to give 10 bonus points to everybody for no reason. So I've got the 5 times the 2x, and I've got the 5 times the -7. Now, here's what's really important. Because this is where the parenthesis ends, I don't take the 5 any farther. Once I hit the parenthesis, I stop everything. So that's why I stopped. I didn't go over to the equal sign. I didn't go to the 15x. All I did is I just stopped because I saw the end parenthesis. Okay, so I've got 5 times 2x, that's 10x. 5 times -7 is -35. And then I just do my math. Now, I always like to move things to the side that has the bigger x. So on the left, I have $10. On the right, I have $15. So I'm going to move the 10 over to the right side. I'm going to do that by doing the opposite. There's no number here. So the opposite of adding is subtracting. So I know this is positive, so I'm going to subtract 10x. And I also have to subtract 10x from here. Now, this is where some kids screw up. They're like, oh, there's a negative 10. Let me put the negative 10x under the negative 10. No, because you care about the x's. I'm subtracting 10 x's from one side, so I have to subtract 10 x's from the other side. And I got to make sure those x's line up. So that eliminates this, becomes 0. I'm not even going to write it. Then I'm left with negative 35. Then, look what happens. 15 minus 10, simple, 5. The x comes down, and I'm left with a negative 10. Again, I'm trying to isolate that variable. So when I isolate the variable, I got to get it by itself. So when I try to get this by itself, I have to get rid of that negative 10. The opposite of negative 10, subtracting 10, is adding it. Because when I add 10 to negative 10, I get 0. I can cross it out. But whatever I do to one side, I'm intentionally changing colors. I did blue on one side, I got to do blue on the other side. So that's where I'm going to add 10 to this side. Negative 35 plus 10, that's going to leave me with negative 25 and my 5x. Again, I'm back in that football situation. I've got the 5x and the x are in a huddle, or not huddle, a tackle. What do we need to do? Divide them apart. So I divide that side by 5, I divide this side by 5, and I'm left with x equals negative 5. Now, if you want to get fancy, you could substitute back in and do that math. I'm not going to take our time to do that. All right, here's another hard one. And this one I put because I wanted to emphasize, do not go past the parentheses. The parentheses is the all stop. That's when you stop sharing, okay? I know in kindergarten we teach you to share. Don't share after you hit the parentheses. So see here, this is this parentheses, this is this parentheses. So the 3 is only touching the red, so then it has to stop. So when I go over here, I'm going to write 3 times x and 3 times positive 2, and then I stop because that red stops it. That parenthesis stops it. 3x, 3 times 2 is 6. Now I've done that first part. Now I have to simplify my next part. Here comes my next part. Here's the parentheses. This parentheses is the stop. So I've got, trick question, negative 2 times x. And then I've got negative 2 times positive 1. Negative 2 times x is negative 2x. Negative 2 times positive 1 is negative 2. And then I'm just left with my good old x equals 8. Okay? Now that the parentheses are gone, now I can do what I need to do to get everything cleaned up. So I'm going to look, okay, do I have any variables? Yes, I have x. So because I have x, that means I'm going to need to combine my like terms. So I'm going to say, okay, well, I have $3 here, and I have negative $2 here. So they're both x's. 3 minus 2 is 1, so I'm left with plain x. Then I have positive 6 here. There's no numbers. There's no variables next to it. I'm sorry. Negative 2, 6 minus 2 is positive 4, and that equals 8. Now, simple one step. The opposite of adding 4 to both sides is subtracting. So I'm going to subtract 4 from this side, subtract 4 from this side. These cancel, and I'm left with x equals 8 minus 4, which is 4. And then this problem is done. So really, it's about just taking your time, one step at a time. Hold on one second. Pardon me. I'm using colors to show you, make sure you keep everything balanced. So if you do something to one side, you need to do it to the other side when you're solving. In this case, I didn't do the multiplication to the other side because I was, until this point right here, I was still just simplifying. I didn't need to do anything on the other side. But after you've simplified and you're trying to solve, then you need to make sure you keep it balanced. This is an example of what they probably would have for something that would be a harder question, where you have to analyze what did they do wrong. So I always get confused on this question. So what I like to do, and you don't have to do it my way, this is just how I like to do problems like this, is I like to just solve it myself. And then I compare what I did to what they had to do. And in this problem, I know there's 2 mistakes. So first, let's solve it without really even paying any attention at all to what the student did. So I have 3 times x, which is 3x. Ooh, you know what we should have done first? Here, we need to move this negative 2 to the other side. That's one thing we could do first. So we're going to add 2 to both sides. which I honestly don't normally do, but that's how they had it done in this problem. So when we do that, this cancels. So we're left with 3 times x plus 4. And then 16 plus 2 is 18. Now, I normally would actually simplify one whole side before I move anything over. But because in this example they didn't do it, I figured we should a little bit follow what they did. So in this place, all they did right here is they added 2 to both sides to get to here. Okay. This stays the same. Then we do our multiplication. So then we know that the right thing to do for our next step is to distribute. And we know when we distribute, we have to distribute to everything in the parentheses. So that means we've got 3 times x, which is 3x. And then we have 3 times 4, which is 12. And that equals 18. So right away, that's one thing they did wrong, because look at, they put 4, they forgot to do the distribution. So this is one thing that they did wrong. After they do that, we have to subtract. So now we're left with 3x equals 6, and then they divide, and they get 2. Or I'm sorry, they get, yeah, this is a 3. This is x equals 2. Honestly, I don't know where else they're going to say is wrong, unless they say... Maybe it is just 1, because I can't imagine 14 thirds, 12, 14. Yeah, honestly, I don't know what. The only other thing I think that they might have said was wrong is, typically speaking, you wouldn't convert it into a whole number and a fraction, into a mixed fraction. So that could be the other thing that was mistaken. Or they didn't get the right answer. But the main thing is they forgot to distribute, and that's what it was testing you on. Okay, now switching to inequalities. Now, when we switch to inequalities, everything is the same except for one thing. The only thing that's different is when you divide or multiply by a negative number, you flip the direction of the sign. That's the only thing that's different. So let's take a look at this problem. Because the strategy I've been showing to you is to move over the variables to the side that's got the biggest the number of variables, you should never have the problem of flipping the sign. So I'll demonstrate it here. Here we've got 2h plus 8 is greater than 3h minus 6. So I look at myself and I'm like, okay, here I have a 2h, here I have a 3h. Well, 3 is bigger than 2. So that means I'm going to move my 2h over. So if I start off with 2h plus 8 is greater than 3h minus 6. Because we know that 3 is bigger than 2, my first step, again, is to move the 2 over. Because this eliminates the need for me to flip the signs because of multiplication or division. 2 minus 2 is 0. The 8 comes down. The sign stays the same. I didn't multiply or divide by anything. And then I've got 3 minus 2, which is 1. So I'm just left with h and then the minus 6. Now I do my next step. Remember, our goal is to get the h by itself. So the opposite of subtracting 6 is adding 6. So I'm going to do plus 6 on both sides. These cancel. My h comes down. Then I have this. 8 plus 6 is 14. Now, here's one thing to think about. The proper standard form is to write the h first. So then what I do is I write my h first. And then I notice I have 1 point by the h and 2 points by the number. So I'm going to write my h, and I know I have 1 point by my h and 2 points by my number. When I do that, that allows me to say, okay, 1 point by my h, 2 points by my number, 1 point, 2 points. Now I can draw my sign in the right direction. So I really would have h is less than 14 as my solution. Now, if I'm drawing this on a number line, which I don't think you'll see something this easy on the test, but let's pretend. Here's your number line. I always write whatever my answer is in the middle. And then I put the numbers below it. So I know I've got 14, 13, 12, and I know I can count up 15, 16. Okay. Then I look and I say, okay, well, I know my magic number is 14, so I'm going to draw a circle at 14. And then I think, okay, is there a line underneath? Remember, if there is a line underneath, that means I'm going to have to fill in the circle. So it's going to look like this. It's going to be a closed circle. If there is no line, then it's going to be an open circle. In this case, there's no line underneath that number, so it's going to stay open. Then, this is my cheating way. Okay, I think of the number 0, and I put 0 in, and I say to myself, okay, is 0 less than 14? Yes or no? Yes. So because 0 is less than 14, I know I'm going to shade in the direction of the 0. And that is how you would plot that line. I love using 0. For me, it's the way easiest way to do the problem. Let's look at another one. Okay, here we've got negative 6x minus 17 are greater than equal, and then the rest of it. So let me write this a little bit longer so I have space, because you know I like to write big. Okay, then we're going to switch it here. If I'm going too fast, please let me know. I notice that 8 is bigger than 6, negative 6. So I'm going to do the opposite. The opposite of subtracting 6 is adding 6. Negative 6 plus 6 is 0. That cancels away. 8 plus 6 is 14x. And then I bring it down. Then switching colors, I've got to move that 25 to the other side. The opposite, inverse operation to addition is subtraction. And then this you might want to do on the calculator because some kids really, really screw up subtracting negatives. Basically, it's like I owe you $17 and I owe you $25 more, so I owe you more money. So it's going to stay negative. But nonetheless, when we do this, we're really adding two negatives together. So you're at negative 42. Then switch colors again, and we've got our tackle going on between the 14 and the x. So we're going to divide and separate out that tackle. This is going to leave me with negative 3. And then again, I do the dot thing that I showed you before. I notice that I have one dot is by the x and two dots are by the number. So when I go to write it the correct way, my x comes first. One dot goes by the x. Two dots go by the number. So I know this is the sign I'm supposed to use. And then I also have the equal. So I got to put that. And then my negative 3. So when I go to graph it, I put my negative 3 in the middle. And then I always have to remember that the numbers actually are going up, but mentally I think that they're going down. It's like backwards. So I got to do that. Then the next thing I do is I draw my circle. I'm going to draw my circle at negative 3, which I put in the middle. I look, does that circle, is it opened or closed? Because I have this equal then, I know it's going to be closed, so I'm going to color it in. And then I do the trick. I put 0. I say, is 0 less than negative 3? No, it's not. So I'm not going to color to 0. I'm going to color the other way. So that means that I need to color this way. If it was, then I'd color towards 0. So if it was like this instead, if it was said, is 0 greater than negative 3? Then I would color, yes, it is. I'd color towards 0. But because it's not, I color the opposite direction. Next, which inequality is shown in the accompanying diagram or in the accompanying graph? Okay, you guys are troopers. Thank you for being here. Let's see. Okay, first of all, I know I've got negative 1. Then I know I've got x. So remember, my hint is I put 0 in for x. 0 is colored in. So I say, is 0 bigger than negative 1? Yes, it's bigger than negative 1. So that means I write it like that. That's it. So because this is closed, I have my line here. Because 0 is bigger than negative 1, I know it's got to open towards 0. That's it. Here we've got a bound. There's 2 dots. So that means there's 2 important numbers. I've got one number is negative 4. One number is 2. And in the middle, I have my x. Well, I think, well, I see that this is closed in. So whatever I'm going to do, I know this side is going to have an equal line and this side isn't. Then I think, okay, is 0 in this line? Yes. Because 0 is in this line, I know I have to face it that way because I have to make sure 0 is bigger. It's in that line. The open part means yes. Then I go here. Is 0 between this part? So now I go here. The only way that you can think about it is like this is the max point here. So you can't have it. You can't have the x be bigger than 2. Okay, the only way the x would be bigger than 2 is if it was like this and going this way. But you always have the less than signs facing the same direction. Okay. All right, next, in order to be admitted, here's an example of how this might be a DOK2. In order to be admitted for a certain ride at an amusement park, a child must be greater than or equal. Holy moly, greater than or equal. So right away, I know it's got to be closed circle. So honestly, I'm not even going to keep reading yet. As soon as it says greater than or equal, I'm going to use the X feature on the interim that you take online, and I'm going to immediately eliminate number 2 and number 3 because right away it says or equal, and these are not or equal. So then I stop. Boom. Now I'm only between 2. Then it says, okay, it's got to be greater than or equal and less than 48. So it doesn't say or equal, it just says less than. So I know my 48 has got to be, where are you, mouse? There we go, has got to be open. So this is closed. So I know it can't be this one. So I'm left with choice 1. So again, if it's equal, it's filled in and closed. If it's not equal, if it just says less than, then we keep it a big open shape, domain and range. Okay. If you guys are still on and want to play the Kahoot, I do have a Kahoot relating to this. We're almost done. You guys are doing great. Which of the following best describes the domain and range? Let's review a couple things real quick. Domain stands for X. Domain goes left or right. So if you are a Fortnite player or any other gamer, domain is how you move on the ground, left and right. Range is up and down. Range stands for the Y. So let's look here. The domain, we typically write with the letter D. And then you typically have parentheses like this, and I probably am going to mess up my notation a little bit. The domain is for X values. Then we draw a little line. And then, actually, I'm just going to use... Nope, this is fine. So X values. And then I know my important numbers in this case are 2 and 8. So here's my 2 and my 8. And I intentionally changed colors because I don't want you to think that that line makes it 12. It doesn't make it 12. It's just set notation. So 8. So 2 and 8 are my important numbers. I know that in the middle of my 2 and 8, I have to have my X. Boom. Okay? Because I have 3 different factors, I know I'm always going to have these signs like this. The question is, are they open circle or are they closed circle? This right here is open circle, so I'm not going to write anything else underneath that sign. It stays the same. This is closed circle. So because this is closed circle, I need to draw a line right here. So for this to be set notation, the official way to write this problem is the domain. Here's my lovely bracket. I've got my X and my bar for set notation, and I'm left with 2, X, 8, and closed my set notation. That's set notation. The other notation is called interval notation, which is way easier. All we do is we write our 2 and we write our 8. Because there is no equal sign there, I'm going to write a curved parenthesis. Because this says a straight line, like boom, I have to make mine a hard bracket. So it's curved parenthesis, hard bracket, like that. That's the domain. The range is up and down, okay, like in Fortnite, how you're jumping. So in range, I'm going to do the same type of thing. Range looks at my Y values. So I've got my Y values. I know my lowest number is 3 and my highest number is 9. So I'm going to write 3, 9. I'm going to write my Y in between. Again, I know my signs have to go like this. And this is open, so I do not put anything underneath that first sign. This one is closed, so I do put it in between my first sign. And then that's done, set notation. I know my numbers again to make it interval notation are 3 and 9. Because this is open, I know I'm going to be curved. Because this over here is closed, I know I'm going to be a hard bracket. Done. Next, which graph represents the axis of symmetry of the graph of the parabola below? Axis of symmetry we get by using the opposite of b over 2a when we're given an equation. When we're given a graph, dude, we just look at the graph. Where does it turn? Where could I fold it in half and it would make it look perfect? So I look, where can I fold it in half? Well, here is where it turns. Here it's going down, boop, 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 down. All of a sudden it hits this point and then it goes boop, 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 up. That's it. So where does that happen? Well, it happens at this point right here. And I have a hard time of drawing lines, straight lines on here because I always tell myself I can't do it. But this would be the axis of symmetry right here. That's it. Well, what is it? Well, let's look. X, because it's on the X. 1, 2, 3. X equals -3. That's the axis of symmetry. If it wanted to know the vertex, all we do is we look at the point. The vertex is the exact point it changes. So it exactly changes at -3, -25, and that's our vertex or our turning point. Okay, let's look at another one. Where does it change? It changes right here, and it folds this way, so I know my line has to go up and down. Boop. Okay, what's the value of that line? Simple, x, 2. X equals 2. What's my exact turning point, my vertex? That's a little bit tricky. It's in between. But what number comes between 12 and 14? 13. Whoops, sugar shoots. So I'm left with my 2 and then my 13, and I'm done. Simple. Let's look at another one with the graph. Okay. Remember, there's 4 questions that relate to interval notation, domain, sketching, things like that. Okay. Intercepts, or not domain, intercepts, positive, increasing, decreasing. And again, let's just take a look at this picture real quick. I forgot to talk about it. Here, picture yourself. You're on a sled. I know there's not a whole lot of sledding in Georgia, but let's say you're at Snow Mountain. What happens? You're going down the sled, so it's decreasing. The slope is negative. Technically, it's not really a slope, it's a parabola, but it's decreasing. What happens when you get to the bottom? You're going up, so it's increasing. That's it. What happens when you're right at the top? You're perfectly level. Nothing happens. That has no slope. And if you're on a cliff and you went straight down, undefined. That's it. Okay, let's take a look here. Here you start here, you're going down, so you're decreasing. Here you're going up, so you're increasing. Okay, simple, simple, simple. Then it says, what's the vertex? Here's the vertex right here. Okay, 1, 2, -1, -2, and 1, 2, 3, -3. That's our vertex. Okay. Axis of symmetry is just the line it turns. That's it. You're going down the hill, then you're going up. Axis of symmetry is that name of that line, that if you folded it in half, where would it be? Again, boop, boop, x equals 2. Oops, x equals -2. Next, now we have to figure out mathematically how do we do this? What's the axis of symmetry? Okay, this is where it's super cool. On your formula sheet, you have a formula that's called the quadratic formula. That is x equals the opposite of b plus or minus radical b squared minus 4ac all over 2a. Now, I can't remember if you learned this in algebra or not yet, but you are going to learn something called the discriminant. The discriminant is all this stuff, blah, 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 blah. It's important, and it's important for solving for x, but for what I'm talking about right now is not that important. So when you have to find the axis of symmetry, all you do is you look at the formula sheet, you look for this equation, and then you throw all this other crap away. Boop, 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 gone. When you do that and you throw away all the ugly stuff, the plus or minus square root of b squared minus 4ac, what you're left with is the axis of symmetry. How cool is that? So here, the axis of symmetry is all it is x equals the opposite of b over 2a. You don't even have to memorize it. All you have to do is open up the formula sheet, cross out the gunk, and everything you got left is how you figure out your axis of symmetry. So here, how I have y equals x squared minus 3x minus 6, dude, I still do my ABCs. And if you don't know your ABCs, take a look real quick. The ABCs is A x squared plus B x minus C. So all you do is you match the stuff up. Here in my case, A, there's no A value, so it's 1. B will be -3, and C will be -6. And I rushed too much. This should be plus C. So now I know A equals 1, B equals -3, and C equals -6. So to find my axis of symmetry, all I'm going to do is plug it in. Here I take X, I put in the opposite of B. Well, what's B? -3. I divide it by 2 times whatever my A value is, 1. Negative times a negative is positive. 2 times 1 is 2. That is my axis of symmetry. Booyah! Now, that's how you do it mathematically. Technically speaking, you could have just typed that whole thing into your equation, into y equals blah, 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 blah. Let me open up my Wabbit real quick. You could have just opened up your, whatchamacallit, graphing calculator, and you could have gone into y equals. And because we're not adding or subtracting anything, you could have just typed in x squared minus 3x minus 6 and graphed it and looked at the graph. Except I'm not in the right mode, I don't think. But that would have been another way. I think I'm in the wrong mode. But that's another way that you could have done that. Hold on. Enter y equals... Not exactly sure why that's not working, but in theory, you could have done that too. All right, next. What are the coordinates of the turning point? All you got to do is the axis of symmetry, and then you plug it back in. So remember, axis of symmetry, again, is we look at the formula sheet. We get that very ugly opposite of B plus or minus the square root of B squared minus 4AC all over 2A. You get that equation from the formula sheet, you cross out the gunk, and you're left with the axis of symmetry. You don't have to memorize it. Then you have to know how to use it, but you don't have to memorize it. Then we take our information from here. This says negative. Remember, there's a hidden 1. So my A is, let me spread this out so we have space. My A is -1. My B is +4. And my C is +1. So now all I do is I just plug it in. Opposite of B, opposite of +4. 2 times A. -4, negative times 4 is -4. 2 times -1 is -2. And then I do the math. -4 divided by -2 on your calculator will give you a +2. That tells you the axis of symmetry is at x equals 2. That's when it flips. Then you take that 2 and you plug it into the equation, and you're going to get your other point for your turning point. So now I have my original y equals -x squared plus 4x plus 1. I'm going to do a substitute. That's it. Super easy. Negative times 2 squared plus 4 times 2 plus 1. 2 times 2 is 4. Then the negative comes out. Now notice how I made sure that I kept this in parentheses. I didn't do -2 squared. I did negative, the opposite of 2 squared. Okay. This becomes 8 plus 1. -4 plus 8 is +4 plus 1 is 5. So my coordinates, 2, 5, done. Again, you could have typed it into the calculator and seen where it turned. We only have like 5 questions left. Thank you for staying on. Which quadratic equation is the axis of symmetry x equals 3? So I like this one because you had to do it 4 times. If it's the last one. Honestly, I don't remember what the answer is. So let's take a look. Remember, we don't need everything. All we do is we look at the formula sheet for the quadratic formula. Opposite of B plus or minus the square root of B squared minus 4AC all over 2A. Again, we cross out the crap. You need it. It's important for later when you learn the discriminant, but for right now, it's not important. So now we know the axis of symmetry is negative b over 2a. Let's take a look here. We know a is going to be -1, and we know b is going to be +3. Here, a is going to be -1. B is going to be +6. Here, a is going to be +1. B is going to be +6. And here, a is going to be +1, and b is going to be +1. And all I did is I looked at these pieces right here. All I did was copy them over. I didn't do anything else fancy. Now, you could write the C value, but you don't need it because the C value is only important when you're finding the roots. So we didn't need it, so I didn't write it. So let's look. Opposite of b over 2a. -3 over 2 times -1. Well, that'll give me -3 over -2, which gives me 3/2, which is not 3. So it's not choice 1. Remember, I'm trying to get 3. Let's go down here. Here, I've got the opposite of b is -6. Good morning, welcome. I've got the opposite of b, which is, honey, just turn off your, excellent. You can turn off your camera. So I've got the opposite of b, which is -6, divided by 2 times 1. Snai, I'm going to just turn off your mic. Welcome, honey. There you go. Okay, perfect. So I've got the opposite of b, which is 6, times 2 times my a, which is 1. So this will give me -6 divided by 2, which gives me -3, but I'm looking for +3, so that doesn't help. Let's look at the top one. Here, so we know it's not 1 and 3. Here I've got 6 divided by 2 times my a, which is -1. And it's the opposite of b, so I really got -6. So here I've got -6 divided by -2. A negative divided by a negative is positive. So my answer is choice 2. All I did was the opposite of b divided by 2a, opposite of b divided by 2a, opposite of b divided by 2a. I can just prove this one down here. The opposite of b is -1 divided by 2 times +1 will give me -1/2. And so you're good. Okay, choice 2. Next, couple more questions, and then we can do the Kahoot if you want to. A ball is thrown in the air from the edge of a 48-foot cliff so that it eventually lands on the ground. The graph below shows you the height of the ball and the ground x's. For which interval is the ball's height decreasing? So think about it. Because it says height is y, this is what I do. On my scratch paper, I write the word height here. And because it tells us x seconds, I write the word seconds here. Because this way, because it says the ball's decreasing, I know it's talking about height is decreasing. So I can immediately think about right here, blah, 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 blah. All that stuff doesn't even exist. It's gone. Cross it out. Because this is where the ball starts going down. Well, where does the ball start going down? I just follow my line. So here I've got 6, or I change my color. I go straight down. Straight down is right here. So the ball starts decreasing at 2.5. So that means I can eliminate choice 1 because that has the ball decreasing at 0 seconds, which makes no sense. They threw the ball up and then it started going down. I can eliminate choice 2 because, again, it started at 0. Then here, this one, it says it continues decreasing forever after you hit 2. Well, nope, because eventually it's going to hit the ground, so it can't be choice 4. So it's going to be choice 3 because it starts decreasing at 2.5. So exactly at 2.5, it's not doing anything. That's why I don't have the line. And it keeps decreasing till it hits the ground at 5.5. All right, I'm going to do that one more time because you very well could get a question like this on your test. So let's look at it one more time. I've never seen your test, but let's just look at it one more time. Again, here we know that height was here. This is our seconds. It wants to know at what point is it decreasing. So I look at my graph and I think, okay, if the height is going up and down, it starts decreasing right here, which matches to 2.5. So I know 2.5 is my main number. So this says it starts decreasing at 0. If it started decreasing at 0, that means it would start here and it would already have gone down. But the ball starts by going up and then it goes down. So it's not going to be choice 1 and it's not going to be choice 2. This one means that it starts going down at 2, but it continues going down forever. And we know that that's not the case. We know the ball eventually lands at 2.5. So that's why I'm left with this one. Because between 2.5 and 5.5, the ball goes down. It isn't going down at 2.5. At 2.5 seconds is when it just starts going down, and it doesn't keep going down at 5.5 because it hit the ground. Let's look at another one. The height of the rocket at selected times is shown in the table below. Based on these data, which statement is not valid? That's the important thing, not. So that means 3 of them are yeses and 1 of them is a no. Okay. We know we have the top is our time and the second one is our height. So the rocket was launched from a height of 180. That means when it started, it was at 180. Let's see if that's true. This is it starting. Is it at 180? Yes, this is true. So that means I know it's not choice 1 because I'm looking for the one that's false. It says the maximum height of the rocket occurred at 3 seconds after launch. So let's take a look. Here it's at 180, then it goes to 260, then it goes to 308, then it goes to 324, and look at, see how it's perfectly matched, 308, 308, 260, 260, 180, 180, because it's perfectly matched. I know the axis of symmetry or the turning point happened at 324. So that is true. Next, let's take my eraser and erase all this extra gunk. Okay, next it tells me the rocket was in the air approximately 6 seconds before hitting the ground. Well, let's see. It started at 0, and even after 7 seconds, it was still 68 feet in the air. So the approximately 6 seconds, that's the lie. Liar, pants on fire. So the answer is going to be choice 3 because that's the one that's not true. The rocket was above 300 feet for approximately 2 seconds. Well, even though we know the answer is choice 3, let's just prove that one. Well, here it was above 300 feet. Here it was above 300 feet. And how many seconds is that? 2 to 3 is 1 second. 3 to 4 is 2 seconds. So 2 seconds. So this is true. So sometimes it's just analyzing a graph or a table to get you the answer that you need. Morgan throws a ball up into the air. The height of the ball above the ground in feet is modeled by that function where t is time and seconds that the ball was thrown. What is the domain? Okay, here is a couple things. Domain is always the one that goes across. Okay, it's always the x. If we go back to here, our domain here was time, and our range was the height in relation to time. So the range is always going to be a relationship. It's always going to be dependent on the domain. Same thing here. Our t is our domain, and our range is the height in terms of the time. So here, our domain is going to have to be time, because the time is always, we can kind of pick what the time is. The range, we don't have any control over. So technically speaking, right now, I can eliminate 3 and 4 because the h of t represents the height, which is the range, which is the up and down. So right away, I can eliminate choices 3 and 4. Then I'm looking at choices 1 and 2. Because I'm throwing something, time exists. So it's not after only between 5 seconds and 9 seconds. It's the whole time. So that's why I have the 0. Okay, so that's good. Now we just have to figure out, okay, is it going to be 9 or is it going to be 1.5? So now we just need to solve. And we solve it by plugging 0 in for the height. Because the ball starts, we're going to pretend the ball starts on the ground. So it goes up and then down. So here we're going to plug in 0, and then we're going to write our negative 16t squared plus 24t, and then we have to solve. First, I'm going to factor out a t to make my life a little bit easier. And then, now what I need to do is I need to set each one of those things equal to 0 and solve it. And that's going to end up giving me my 2 values that I need. So here I'm going to say t equals 0. Because the reason why I'm setting each one equal to 0 is because it's a multiplication number. And we know anytime we multiply 2 things together, our answer is, anytime we have something that equals 0, one of the 2 things have to be 0 in order for us to get 0. So that's why we have to set each of those ideas equal to 0. So t equals 0, we already know that. Now we solve our next one. Negative 16t plus 24 equals 0. So I'm going to subtract 24 from both sides. That leaves me with negative 16t equals negative 24. And then I don't feel like doing this math in my head. I can estimate the answer, but on my trusty calculator, I've got negative 24 divided by negative 16, and I'm left with 1.5, which is my answer. These are eliminated. T equals 1.5. So that means my answer is 1. Okay, so sometimes it's just solving and keep moving on. All right, here I think we've got 3 more problems and then we're good. John left his home and walked 3 blocks to his school as shown in the graph below. What is one possible interpretation of the section that happened between B and C? So let's take a look. The main thing to pay attention to here on the graph is the labels. So here this says distance. So picture here is John's house. Hello, John's house. And here is John's school, which I'll denote by the American flag flying in outside the school. So if he walked 3 blocks, what happened between B and C? Well, we know that between B and C, time happened, but John wasn't moving. And we know John wasn't moving because moving is up and down, time passing is left and right. So John arrived at school and stayed throughout the day. Well, we know school is up what the flag is, and John's not at school yet. So, not choice 1. Choice 2. John waited before crossing a busy street. That's possible because he was standing, he wasn't moving, but time kept going on. So I'm not going to circle that as my final answer yet, but I'm not going to cross it out either. That's a maybe answer. Let's look at another one. John returned home to get his math homework. Oh, math homework. Well, in order for John to return home, he has to have gone back to his house. He didn't go back to his house, so it can't be number 3. John reached the top of the hill and began walking on level ground. There's nothing here that talks about height. Everything is distance, so that is just there to throw you off. So the answer is choice number 2. Okay, if you have questions, please let me know. For the following problems, you have 2 questions on slope-intercept form. For the following problems, find the slope and the y-intercept of the line. Okay, we have slope-intercept form is y equals mx plus b. When we have y equals mx plus b, and I'm not sure that that's in your formula sheet, I think you have to know that in your noggin, y stands for the y coordinate. M stands for the slope. X stands for the x coordinate. And B stands for, hold on one second. What's this pen? B stands, that is very interesting. B stands for the y-intercept. What an interesting combination. So here when it says, what's the slope of the line? I can't even tell you how ridiculously easy this is. When it says, what's the slope of the line? The slope is whatever comes before the x. That's it. Here's the x, okay? My x is right here in blue. Here's my x right here in blue. So my x is whatever, or my slope is whatever comes before the x. Boom. My slope is 4/3. Right here, 4/3. So I already know my answer is D, but let me just continue showing you. My y-intercept, and the y-intercept is just a fancy way of saying where does it touch the y-axis. My y-intercept is whatever comes after whatever the constant is afterwards. So here, my y-intercept is -3, -3. That's it. Now, if I wanted to graph this, and I will show you how to graph it just because it's fun. Well, it's not fun, but you really need to know it. Here we have our axis. It says y equals -3 is my intercept. So I'm going to go here. Here's my intercept. I didn't draw a straight line. And then it tells me I need to go with a slope of 4/3. So that means I'm going to go up 4, 1, 2, 3, 4. And then I have to go over 3, 1, 2, 3. Up 4, 1, 2, 3, 4, over 3, 1, 2, 3. And pretend I'm doing this on a coordinate plane. And then you connect your lines. And that is how you would graph that line. All right, this one's a little bit trickier, and it's trickier because it doesn't say y equals. You always got to make sure it's in y equals 4. So this is where literal equations comes in. So here I have here I have my y. I'm trying to get my y by itself. So I want more space, so I'm going to write big up here. 14x plus 4y equals 24. I'm trying to get my y by itself. So the first thing I'm going to do is I'm going to get rid of that 14x. And all I'm going to do is I'm going to write minus 14x from both sides. Now, I'm left with 4y equals 24 minus 14x. And all I did that is because I knew that when I write my 4y here, this canceled out. So now I'm left with that. Then I'm going to divide everything by 4 because I need to get 4 by itself. So I'm left with y equals, well, negative 24 divided by 4 is just negative 6. And then I can simplify that to be negative 7/2 x. Now that's not technically in y equals mx plus b form, so I'm just going to rotate and switch stuff around. So instead of it having the intercept first, I'm going to rewrite it so the negative 7/2 comes first, and then the negative 6 comes second. That's it. Then all I do is I find my colors. So remember, anything that becomes before the x is my slope. So here's my x value right here. So that means my slope has to be whatever comes before it, negative 7/2. So I know that I'm either going to be picking B or I'm going to be picking C. Okay. Then I need to find my y-intercept. My y-intercept is whatever comes after the slope. So that's this, negative 6. So my answer, ooh, why did I put negative 6 and they had positive 6? Oh, because I didn't know how to do math. Positive 24 divided by 4 is positive 6. That was my mistake. And this should be positive 6. I was rushing, which means this is positive 6, which means this is our correct answer. Okay, so I have been doing this all mother talking the whole time. We do have time to play a Kahoot if you want to. So if you want to play a Kahoot, please go and type yes. Otherwise, we will end and I will get ready for Algebra 2. So if you want to play a Kahoot, we can play it. I have a Kahoot on domain and range. But I'm not going to put it up unless people actually want to play it. Also, someone else logged on. Oh, yeah. Let me write that down. Okay, so I don't see anyone, so we are not going to play the Kahoot. I'm going to end the video recording here. Thank you guys so much for signing on. I will post this video to gwinnetmath.com, and you can share it with your friends, and you can catch up and get ready for your midterm. Thank you guys so much for participating. You are awesome, but you knew that already. Okay, ciao.